Welcome to dividing radicals. So when you have the quotient rule when it comes to radicals is when you have numerator and denominator with division, you can actually combine them under the one radical if the radicals are exactly the same. So they have to be the same cube root, square root, they have to be the same. So n, and then you would do a divided by b. Now you're only going to do this if a and b are divisible by each other. So let's take a look at this. So number one, I see that 160 is divisible by 5, so I'm going to use the quotient rule. First in front we have our fraction 12 divided by 2 is 6. And then I am going to combine, since they're both square roots, combine the radicals together. And 160 divided by 5 is 32. So that's going to be 6 square root of 32. And then we're going to simplify square root of 32. Biggest perfect square that can divide out of 32 is 16. And we have a 6 on the outside. Square root of 16 is 4. Square root of 2. 6 times 4 is 24. Square root of 2. There's our final answer. I'm going to skip the fourth roots. Let's go to number 3. I can see I have like bases, so I can simplify. Like bases, I can simplify, so I'm going to combine them under one radical. X to the third, y to the ninth, x squared, y to the fifth. And when I'm simplifying, look at our like bases. With division, you are subtracting the exponents. So I'm going to have it, that's going to be the square root of x. And then the y to the ninth, we have y to 9 minus 5 is 4. So it's y to the fourth. These are all in the numerator, the resulting answer. And the reason why they're all in the numerator, if you look at your exponent, or the exponents, the biggest exponents are in the numerators. So I always take the biggest exponent, subtract the smallest, and where the biggest exponent was is where the resulting answer is going to be. So, and then let's look, can we simplify any further? Well, x to the first, I cannot take out a grouping pair, so no. And then y to the fourth, you can take out two groups, so it's y squared. And here's our final answer. All right, number 4, I have the coefficients out front. I'm going to divide those first, so that's 7. And then I can look inside the radical and see that I can divide the negative 16 by 2 and m to the 6 divided by m. So I can actually, I'm going to combine these. The cube roots, I'm going to have negative 16 over 2 and m to the 6 over m. So that's 7 cube root. Keep it under the cube root. Negative 16 divided by 2 is negative 8. M to the 6 divided by m to the first is m to the 5th. Looking to simplify this, I have the cube root of negative 8 is negative 2. M to the 5th, I can take one group of 3 out. And we have resulting is m squared. And then final multiply your coefficients. 7 times negative 2 is negative 14. M cube root of m squared. There's your final answer. All right. Let's take a look at their next ones. We already have it combined. 48 divided by 16 is 3. We have 48 divided by 16 is 3. The square root of 3 is not simple. We cannot simplify it any further. We have in our next one, we have 40 divided by 27. I cannot simplify that. So then I'm going to look into breaking it up. And the numerator, I'm going to look to simplify that. And the cube root of 40 is 8. And the cube root of the 27 in the denominator simplifies to 3. In the numerator, we have the cube root of 8 is 2, cube root of 5. And that's over 3. I look then to see if I can simplify my coefficients. 2/3, I cannot, so this is my final answer. Next problem, we have cube root. 7 over 64 cannot simplify, so I'm going to break this up. See if I can simplify the parts. 64y to the 6th, and I actually can. The numerator, I can only simplify the x to the 5th. I can take out one group. 7x squared over cube root of 64 is 4. Cube root of y to the 6th, so you can take out two groups, so that's y squared. Looking at the numerator and denominator, coefficients, anything I can simplify? No. That's my final answer then. And the last one, that's a fourth root. We'll take that off. So this